Hello and welcome. In this video today we're going to be looking at Beta Plus Decay. This video is a direct follow-on from the previous one on Beta Minus Decay, and as you'll see throughout the video today, the two are incredibly closely linked together. Beta Plus Decay occurs when a nucleus has an excess of protons and involves the decay of a proton into a neutron with the emission of a positron and an electron neutrino. If we look at that in equation form, what we can see, we have one proton decays into a neutron, a positron, which is an electron with a positive charge, and a neutrino. In the last video on Beta Minus Decay, we were looking at an antineutrino. To indicate an antiparticle, we have a line over the top of the V. In this case, because we have a neutrino, we do not need that. Okay, so as with all equations, we need to make sure they're balanced, and Beta Plus Decay is no different to that. It's important that we ensure that the atomic number or charge is conserved throughout the process. So the general equation, AZX, our initial element, decays into a Z minus 1, lose a proton, get a new element, plus a positron, and a neutrino. Now, as we can see, our plus 1 charge is balanced out by our minus 1 here, and our 0 charge here, giving us a net constant charge across the equation. If we think about this in a real life setting, and we say we have the Beta Plus Decay of manganese 50, how this would look is that decays into A stays the same, Z is minus 1, so 24, and we can look up the periodic table to see what has 24 protons, and in this case we are left with chromium, and the rest of the equation, essentially this section here remains unchanged from the formula, so we're left with 0 plus 1 positron and a neutrino. So the main calculation you need to be able to do is Z minus 1. An exam testing style question that you might be likely to see. Nitrogen 12 undergoes Beta Plus Decay to form carbon, or carbon 12 as you're told in this example. Write an equation for this. First thing you'll do is you'll write down your initial element, and then we'll go through the process to unpack it again. A stays the same. Z minus 1 gives us 6, which means we left decays into carbon. We are actually told that in the question. And again, this last bit of the equation, there's nothing that you need to do on that except for writing it down. So nitrogen 12 undergoes Beta Plus Decay. Our nitrogen 12 decays into carbon 12, and we have a positron and a neutrino left over. Thank you very much.